In this section, we'll implement and verify the private VLAN configurations. So if you remember, we already discussed that private VLANs can be implemented to prevent the host within the same VLAN from communicating directly. Now in that, we got two types of VLANs. We have something called primary VLANs and secondary VLANs. So primary VLANs are the main VLANs, and in that we are going to create multiple secondary VLANs. And again, in that secondary VLANs, we got two categories: isolated and community VLANs. Okay, we can assign the secondary VLANs to any one of these categories. So isolated will not communicate with any other isolated port. Community ports or community VLANs will communicate only within the same community. Now every port can be configured. Either it can be promiscuous ports which can communicate with all the hosts, including isolated, whereas the host ports can only communicate with a promiscuous ports, or they can only communicate within the same community private VLANs. So this is our lab scenario which we are going to use for verifying the private VLANs. So for verifying private VLANs, I need to have a switch. So I got switch 1, which is my 3560 switch, which is acting as my centralized device, which is going to connect to all my customer sites. Let's take an example here. Router 1 and router 2 belong to one of my customer site ABC, and I want to ensure that any traffic coming from router 1, router 2 also should be able to access that. So all belongs to the same physical subnet. They are all on the same subnet, and at the same time they are all belonging to the same primary VLAN. And in my scenario, I'm going to use the primary VLAN as VLAN number 10. Now in that, again, I'll be creating some multiple secondary VLANs, and I want to ensure that the customer ABC should be able to communicate with the other sites within the same customer site. Let's say router 1 and router 2 belong to the same company or the same organization, and they are connecting to a centralized switch. Now similar way, I got a company XYZ here, and I want to ensure that this router 5 and switch 2 belonging to those customer XYZ sites, and they should be able to communicate with each other automatically. And at the same time, I got another customer. Let's say this is my customer PQR, and this is my customer some X. Okay, I want to ensure that the traffic coming from this customer should not go to any of the other customer sites. Okay, so that's the reason I'm going to make it as isolated here, and then the same thing applies for 1.4 as well. So they are part of the same physical subnet, and also they belong to the same primary VLAN. And then finally, all the customer sites, all the customers like ABC, XYZ, PQR, and some X sites, all must be able to access internet traffic which is connecting on switch 3. Means that's what I'm going to configure this particular port as promiscuous ports. You can see the diagram here. So I'm creating multiple VLANs here. So where VLAN 10 will be my primary VLAN, in that primary VLAN I'm going to create one more secondary VLAN which is 100, which belongs to this community, and they will only communicate within the same VLAN 100. And then I'm going to make one VLAN as 500, which will be my isolated VLAN. And then finally I'm going to make one more VLAN which will be my community VLAN again, which will be 200. Now these users can communicate with each other, talk to each other. These can talk to each other, and these two are totally isolated. They will not talk to any other site except the promiscuous port. So they all can access this. So this is our verification. So in the lab, I did most of the pre-configurations already. I have my devices connected the same way you can see here on the switch 1, and I also have the IP addresses pre-configured. So I did that pre-configuration, and I did not do anything other than that. So just an IP addressing on the customer side, and then all the physical connections exactly the same. Let's try to verify, getting into the console screen here. So I got my switch 1 here. You can see the output here. You can see the console connection here, the CDP neighbors here. It's exactly the same way I have the diagram here. You can see switch 1 is going to connect to all the devices with the same exact ports, If I go to each and every device and if I verify show IP interface brief, and I already have the IP addressing pre-configured here, and if I try to verify, I think they are in the same VLAN. I'll try to verify the ping, the connection between router 1 and router 2, and I'll try to verify the communication between router 1 and router 3, and then switch 4. Switch 4 is acting as my router 4, which belong to this side here. So you can see the communication is there. Similar way, if I try to go to 1.5 and same as 1.6, so which is my switch 2. So I should see the reply, yes. And finally I have switch 3, which is acting as my internet route. It is configured with an IP addressing of 192.168.1.10. You can see the communication should be there. So all the devices are connected properly, exactly the same way, and these are the ports which I'm using. Now anyway, by default they belong to the same VLAN, and if I verify my VLAN configurations, they belong to the default VLAN, which is my VLAN 1. Anyway, as long as they are part of the same VLAN, they can communicate. Now my requirement is I want to ensure that this R1 and R2 should communicate with each other. They should be a part of the same community so that they can communicate with each other. Same thing applies for PHY and switch 2, and the same, and these two ports must be isolated, R3 and switch 4, and they all must be able to communicate with a promiscuous port. So I need to configure VTP in this scenario. So the first step we are going to do here is configure the VTP mode as a transparent mode on all the ports connecting to the end devices in the VLAN 10. So which means the first thing, in order to configure the private VLAN, the switch has to be in a transparent mode, and then we are going to assign all these ports, whatever the ports connecting to the end devices, they will be a part of the VLAN 10. So that's the first step which we'll do. Let's try to do that. Okay, so to do that I'll go to switch 1 and I'll say interface range command. I'll start with interface F0 by 1 to 3, which is my R1, R2, R3 connections, and then F0 by 22, which is connecting to switch 4, and then F0 by 5, which is connecting to router 5, and then switch 2, the port is F0 by 24, and then finally F0 by 20. I'm going to assign all these ports into my primary VLAN. So in my scenario I'm going to use primary VLAN as my VLAN 10. So they all belong to the same VLAN, so which means they can still communicate with each other, but I want to ensure that they should not communicate with each other and as per my requirement by using private VLANs. So the first thing you need to configure is you need to configure the switch, whichever is configured with the private VLAN, it has to be in the transparent mode. So that's what I did here. So my switch here is in transparent mode. So the next step, I'm going to create a VLAN 100, 200 and 500, which will be acting as my secondary VLANs, where I'm going to use 100 and 200 as my community VLANs, and VLAN 500 has to be my isolated VLAN. Okay, VLAN 100, 200, 500 will be acting as my secondary VLANs, and they should get associated with my primary VLAN, that is VLAN 10. And to make this possible, so we'll go and configure these commands here. So the first thing, we already did this VTP mode transparent, and we have shifted the ports in the respective VLAN 10, all the ports. Now I need to say VLAN 10, the first step, VLAN 10 private VLAN primary. So I'm going to say private VLAN, and then I'm going to say primary. Okay, so now VLAN 10 will be my primary VLAN, and then VLAN 100, I'm going to create VLAN 100, and then VLAN 100 will be my community VLAN. You can see here I'm going to use VLAN 100 as my community VLAN, and then I'm going to create VLAN 200, which will be also my community VLAN for different customer sites. And then I'm going to create one more VLAN, VLAN 500, which will be my isolated VLAN. So I'm going to say isolated. Done. So now I created 4 VLANs here. If you verify, So I created VLAN 10, which is my primary VLAN, and then I have just created VLAN 100, 200, 500. They will be acting as my secondary VLANs. So as of now, they will be primary VLANs because I did not associate. So what I'm going to do is I'm going to associate my primary VLAN with my respective secondary VLANs. So next step is I'll go to VLAN 10, and then I'll say private VLAN association, and I'm going to add my secondary VLANs, VLAN 100, 200. Okay, so no commas, 100, 200, 500. Okay, so it has to be separated by commas without any spaces here. Now once we do this, now to verify, we can give a command called show VLAN private VLAN. When I try to verify, you can see this is my primary VLAN, VLAN 10, and I got 3 separate secondary VLANs which I created, and I assigned 100, 200 as community VLANs, and then 500 will be my isolated VLAN. Okay, so next step is, so once we create a primary VLAN and then we have associated our secondary VLANs, the next step is we need to assign our specific ports into the respective VLANs, respective port types, we can say. So the first step what we'll do is we'll try to configure this port number 20 here. This port number 20 will configure it as a promiscuous port. Now promiscuous port do not belong to any VLAN. It's a type of the port which can be accessed by any other type of secondary VLANs. So port number 20, which is connecting to my switch 3, and we need to say switch port mode private VLAN promiscuous, and then we have to do mapping. Okay. So I'll go to my switch 1 and I'll try to configure this respective ports, port number 20 which is connecting to my switch 3, and I'll say switch port private VLAN, and then so first thing I'm going to say switch port mode, and then I'm going to say private VLAN, and this port is promiscuous port. After that, switch port private VLAN, and then I'm going to say association, where I'm going to say host. Okay, sorry, mapping. So when we are doing the isolated or community ports, we use the host command. So we are going to say mapping, map our primary VLAN, which is our primary VLAN 10, and then I'm going to map my secondary VLAN. Secondary VLAN means what are the VLANs traffic can be allowed, whichever coming from the secondary VLAN here. So in my scenario here, it will be 100, 200, and 500 will be our secondary VLANs, which this traffic from these VLANs will be permitted. So I'm going to say 100, 200, and then 500. Done. So once we configure our specific port into promiscuous, the above command is going to assign the port to a primary VLAN, and it's going to map your VLAN 100, 200, and 500. The next thing what we'll do is we'll try to configure port number F0/1 and F0/2, which is connecting to router 1 and router 2, which belongs to the same community or the same organization, and I want them to be a part of the community VLAN, and that VLAN is 100. So let's try to configure those two ports so that they can only communicate in between them, and they can also communicate with the promiscuous. So I'm going to say interface range F0/1-2 switch port mode, and if we say private VLAN, and the private VLAN is the host mode. So whenever you are assigning any specific port other than promiscuous, we generally configure as a host. If you are assigning a promiscuous port, then we configure it as promiscuous mode. Just the command starts with switch port mode, remember that, and switch port private VLAN, and then we have to say association mapping, it's host association, and then we need to define my primary VLAN, and then we have to define the secondary VLAN. So I'm going to associate this port number 1 and 2 as a part of the VLAN secondary VLAN 100, which is again it's a community VLAN. Now same thing we need to do for the remaining 2 ports here. I'm going to do the same thing for community VLAN 500. If you verify the commands, so I'll apply the same thing for interface F0 by 5 comma F0 by 24. 24 is my port which is connecting to switch 2 and router 5, and then the command will be the same command, switch port mode private VLAN host, and then I'm going to say switch port private VLAN host association, but this time I'm going to associate with my community VLAN 200. So already we defined that VLAN 200 belongs to a community VLAN, so we did that already. Now the next thing we need to do is we need to assign these 2 ports connecting to router 3 and switch 4 as a part of isolated. So I'll go to interface range F0 by 3 and then F0 by 22. Now here also the commands will be similar. If you verify the commands, we need to simply say switch port mode private VLAN host, sorry, not this one, switch port mode private VLAN host, and then switch port private VLAN host association and associating with the VLAN 500. So we don't define it exactly with isolated. When we define 200, it automatically will be your community VLAN. And okay, let's do this commands, switch port mode private VLAN host, and then switch port private VLAN host association. My primary VLAN is 10 and my secondary VLAN will be 500. So if you remember, we already associated the VLAN 100 with community, and what are the ports assigned to that? Port number 1, port number 2, and port number 20. So promiscuous, you can see promiscuous port is listed in all the secondary VLANs category, and you can see VLAN 200, that is my community VLAN here, port number 5, port number 20 and 24. And the same way I have isolated ports, and they will be isolated with each other. They will not communicate 322 and F0 by 20. So now the last step we need to do is we need to verify. So we did as per our requirement. Now if you verify show private VLAN, we did that just now. And then if you try to verify with this command, show interface status connected, you'll find it also lists your primary VLAN and with secondary VLAN here. Now verification, when you try to verify router 1, I'll start with router 1. Now router 1 belongs to, so it can communicate with 192.168.1.2 because it's a part of the same community VLAN, and then it can also communicate with 1.10. But if I try to communicate with 1.3 or 1.4, 1.5, 1.6, it will not be able to communicate, and the reason is it's just very simple, because even though they are part of the same subnet, even though they are part of the same primary VLAN, but still they are differentiated. So we are just creating secondary VLANs inside that, separating the traffic. A similar way you can try communicating with 1.4, 1.5, 1.6, you will not be able to communicate. So let me try to check from router 3, which will be my access port. Let's try to verify from the isolated ports here from the router 3. I'll try to ping my promiscuous port, which is 192.168.1.10. I should be able to get the reply. You can see I'm able to communicate with 1.10, but if I try to communicate with any other host here, I will not be able to communicate, because isolated port will not be able to communicate with any other isolated port here. Now similar way you can try and check with any other host here. Now finally we'll try to verify our community VLAN 200. I'll go to router 5 and I'll try to communicate within the same community VLAN, which is 192.168.1.6. I should be able to communicate with 1.5, 1.6. They should be able to access each other, but at the same time they can access the promiscuous port. They can communicate with the promiscuous port as well. But if they try to communicate with any other community VLAN like VLAN 100 or isolated, they will not be able to access. So this way we are going to differentiate the traffic in the same VLAN by using the concept of private VLANs.